Good afternoon. I see it's 1 o'clock. Do we want to wait the courtesy 1 to 2 minutes before we get started, or should we just start now? Any preference to our facilitator or Lauren?
You can find some information about some case studies, watershed case studies of kind of utilizing this manual, as well as some other information for thinking about practices within a field and what might work. So there are some watershed case studies on in-field practices, redefining the field edge, and so forth. So if you go to the Conservation Learning Group website at Iowa State University Extension and Outreach, you can find more information on that. So with that, I'm happy to answer questions that you all may have.
Thanks so much, Matt. Do you have like a date? You just said soon on the updated manual.
So yeah, that's a great question. Actually, within the next 2 weeks, you could probably order a hard copy of the new one. The thing is, they have to go through some accessibility things for the electronic version, so that may be more like a month away. So if you want a hard copy, which they are free of charge, just at the only thing you'd have to pay is shipping from the extension store. Although if somebody wants one, send me an email and I bet we can get one sent out to you. So I don't know how many people are on here, Lauren. So if there's 500, that wouldn't be good, but we can get some sent out. And the hard copies, I think they're going to printing actually next week. So.
Thanks, Matt. So if that's okay, we'll hold questions to the end,
Okay,
and then
great.
We'll kind of loop those in with the discussion, and then we can kind of move into Adam's presentation next. So, so Dr. Adam Chambers is our next presenter, and he's with NRCS's Energy and Environmental Markets team, focusing on leveraging markets that value ecosystem services, building strategic partnerships, and getting more conservation on the ground. He has over 2 decades of experience, also working on applied sciences and reducing air pollutants and greenhouse gases. So without further ado, Adam, you have the ability to advance your slides, and you can go ahead and do that, and let me know if you want me to advance them instead. You're currently on mute.
Go off of mute here, and then I'm not seeing the slide presentation. Do you have it up? Maybe that's just me.
You go. Can you advance to the next arrow? That'll be your next slide. I can do that too. Here, 1 sec.
There.
You seeing that now?
There we go.
Let me give you back presenter. Okay.
Not seeing it. Maybe. How about we go with the other approach?
All right. Well, just cue me then.
Okay. All right. Thank you for the help. I appreciate it. My name is Adam Chambers. I work at NRCS. Work out of the West National Technology Support Center in Portland, Oregon, but I work nationally, and I'm a climate scientist by training. All I've ever worked on is atmospheric work. And so today we're going to talk a little bit about this climate smart agriculture and forestry that was referenced at the very beginning, and kind of the fundamentals, the underpinnings, if you might, of what is climate smart ag and forestry from an NRCS perspective. So we can advance to the next slide. I think what I hope to send you home with today, or virtually home at least, is that our working lands in the United States can deliver these voluntary, real, and quantifiable atmospheric benefits. We're calling these climate solutions. And of course, while being productive agriculture, not taking land necessarily out of production unless they're highly erodible soils or other things like that, but actually working with the systems to enhance carbon sequestration and or reduce greenhouse gas emissions. So if we go to the next slide, I usually have this automated, but the system we're working with today doesn't allow it. So if we start with the global balance, we have on the left carbon sequestration and greenhouse gas mitigations, and then on the right we have climate adaptation, climate change adaptation over time. We know that both ag and forestry are doubly exposed, right? They can be sources of emissions, but they can also be huge sources of reductions in emissions. And then the unique components to ag and forestry are we can go below zero, right? We can decarbonize the atmosphere, where other sectors may only be able to go to zero emissions, we could go actually to a negative, and we can move carbon into our systems. Some of that may actually make our systems more healthy, or what some people are calling regenerative, other people call sustainable. So if we make modest investments now in mitigation, remember these are long-term, long-lived gases. They stay in the atmosphere for a long duration. It will reduce our investment in the future. So that's if the left side up arrow is a modest investment now, the right side down arrow is less adaptation investment needed in the future. Then if we flip that around, if we don't make the investments now, we'll just continue to put more gases in the atmosphere. Again, the gases live in the atmosphere for a very long time, and kind of insulate the atmosphere, causing the global warming effect. And then we have more investment needed in the future for climate change adaptation. So it's kind of, can we make investments now that improve our future lifestyle, and how can we do that within the ag sector? So the next slide, going to just talk briefly. This is a nice slide that was compiled by Amy Swan at Colorado State, and it was published by the Intergovernmental Panel on Climate Change in 2006. What we have here is, we know that every ag system is different. Every farm, every ranch, every private forest land, everybody's operating slightly different. There are a large number of sources. There are a large number of mitigation opportunities. There are a large number of sinks, but those are all specific to everybody's individual operations. And we all know one thing about ag is every operation is a little bit different. So, so we try to meet people with voluntary conservation practices in their farm and ranch, and that's, you know, essentially NRCS. In the upper left corner of the picture, you see the greenhouse gases that we're focused on are carbon dioxide, nitrous oxide, and methane. And we're looking for an intervention. So if you look over to the right, in the kind of right of the sunshine there, we're looking for interventions in the nitrogen cycle and the carbon cycle. And we're trying to find those opportunities to reduce emissions, enhance carbon sequestration. And we think we can do that with participation of agricultural producers. So if we go to the next slide. Within NRCS, we have the fortune of a portfolio of working lands conservation practices that we can work with producers to voluntarily implement. We know that these can work, and we know that they can work as climate solutions. So everything from conservation buffers, cover crops, tillage, grazing management, anaerobic digesters, etc. So if we go to the next slide, we'll just talk through a couple of visuals here. I typically have this in an automated format, but you'll see on the left there's a great conservation intervention opportunity. We talked about multiple benefits, co-benefits, ancillary benefits at the beginning of our discussion. You can see if we put a grass waterway in, for example, we can have soil health, water quality, atmospheric carbon benefits in the right side. So conservation opportunity left, conservation implementation right. We'll go through a couple of these just to give everybody a general idea. So we'll go to the next slide. We have grazing management plan. Obviously, there's opportunities for soil health, atmospheric carbon, livestock health, sustainability. And so you can see on the left, there's both a forage opportunity, a soil health opportunity, an animal health opportunity. Then we can work with a producer on grazing management to implement those practices on their particular operation. So if we can keep going to the next slide. Obviously, this one's easy to see. Where's the opportunity for conservation? We have a great soil health intervention, riparian opportunity, sustainability or regenerative agriculture, and carbon sequestration. So you can kind of see left is the opportunity, right is implementation of that. So if we go to the next one, I think this will be the last of our slides. So this is yet another climate smart conservation practice implementation opportunity. Obviously, the left is a degraded system. We're losing carbon out of that system. So it's becoming a source of emissions. And the right, we're trying to stem that source of emissions and actually build carbon, build soil structure, do all the things that we know that we can do with voluntary conservation practices. So those are what we're putting into this basket that we call climate smart conservation practices. So if we go to the next slide. I'm going to put this, or I'll put this in the chat and also distribute it to you. This slide is actually out of date, so I intentionally left it in here. But the new slide is more of a pamphlet booklet, and I see it just went into the chat. So thank you very much. And what that is that's all the practices that we deem climate smart at NRCS, and we're trying to grow that list. We have about 170 practices. We have about 33 on that list right now. As we develop quantification methodologies for those practices and then assure that the practices actually provide some atmospheric benefit, we can bring those onto the list. Not this list is out of date, but the list that's in the chat that's distributed to everybody. So we've got a lot of resources there on the NRCS website that I'd like to point you to as well. Okay, if we go to the next slide. So there's one really interesting opportunity, I guess. You recall at the beginning, I said ag and forestry have this unique opportunity to draw down the atmosphere or reduce emissions in the atmosphere. There's another component of this that I guess we've touched on over the years and learned a lot about. I call this the conservation legacy effect. I needed to come up with some terminology. And then obviously within the federal government, we needed an acronym. So I came up with CLE. And what the conservation legacy effect is, it's best demonstrated by rings of a tree. So let's assume that this tree that we're looking at the cross section of is a participant or a member of an NRCS windbreak. And so this tree is part of that windbreak. You see that the lower red box shows 3 circles, concentric circles, and those are the years that NRCS may have contracted for that windbreak. But then we know that the conservation legacy effect occurs. We also know that trees grow year after year after year. So as long as that tree is not cut down, we accrue additional carbon over time. So the NRCS contracting time is one benefit, but then we get all of this additionally accrued carbon. I'm using the tree rings as an example because it allows me to think of how the system works. But you can also think of this in soil carbon systems where they kind of build upon themselves, and we get another thing that I like to refer to as compounded carbon interest. Really, that's all that's happening here is we're getting carbon built upon carbon. And so healthy soil systems, you can see that happens as well. Once they start to grow and build carbon, and if you keep nurturing that system, it will grow and continually accrue carbon over time. So at NRCS, we work on the quantification both of the 3 rings in the center and then also the legacy effect and looking at how different practices stay on the landscape or maybe different practices disappear from the landscape after a contracting time frame. So that's the way we look at it. We think that this is opening up some new quantification space for the conservation community at large. So if we go to the next slide. And then, within NRCS, you can see we're at about 80 million metric tons of CO2 equivalent per year. Some of that is the direct benefit, which is the black line. Some of that is our legacy over time. Obviously, the legacy over time is indicative of that compounded carbon interest. And we calculate that by conservation practice. So if we go to the next slide. Within NRCS, we have a number of tools that are kind of at our feet, and we have invested in those tools also for you all to use. We start with the National Greenhouse Gas Inventory. Then we have developed a couple of quantification tools for the farm and ranch level calculations. So we've got the Comet Farm tool, and then we've got another, really it's a super easy to use tool called the Comet Planner tool. And so that puts a calculator into the hands of a conservation planner. So what if you decide to put 100 acres of conservation cover, or that cover crop that we talked about, or livestock management, prescribed grazing? What if you want to put that into your county? What would be the benefits that you could anticipate? So the planner tool actually allows you to say, okay, I'm going to go from a baseline to a conservation scenario, and what are the atmospheric benefits associated with my system? That's going to be pretty much focused on those NRCS conservation practices, approximately the 33, and then the different derivatives of those, or the different implementations. So leguminous cover crop or non-leguminous cover crop. Obviously there we're going to have some nitrogen cycle differences. And remember back to that graphic on the nitrogen cycle. So if legumes sometimes emit a little bit more nitrogen back to the atmosphere as N2O. So it could be a slight source. The Comet Farm tool is very specific. It's going to pull your parcel, the digitized parcel that you use. It's going to pull meteorological data, so weather history. It's going to pull soils data underneath that parcel down to 30 centimeters. And it's going to then ask you a whole bunch of questions about how much nitrogen you put in the system, how much carbon you put in the system, what the C to N ratios of compost that you may have applied, or what type of fertilizer you've applied. And then it's going to run calculations of that nitrous oxide, methane, and of course, carbon dioxide and carbon sinks as well, carbon. So if we go to the next slide. Within USDA, we also have invested in these quantification methodologies, and we're investing in those for you all. So you can have tools at your fingertips. This is quantifying greenhouse gas fluxes in agriculture and forestry, methods for entity scale inventories. This document is it's about 600 pages, and it's just chock full of calculation methodologies. This serves as the backbone of the Comet tools that I just talked about. So this is the documentation of how you would perform calculations within that Comet tool, and then we implement that. And our partner there on the Comet tools is Colorado State University. We've had this long-standing partnership with them. So we've got a lot of publication, a lot of quantification methodologies. So we have tools to help people put conservation on the ground, and now we have tools to help people deliver the quantification of that conservation practice and how it affects the atmosphere. Some have an emissions to the atmosphere, some pull carbon out of the atmosphere, or some just reduce emissions. So if we go to the next slide. Here are the two websites for the tools. Just wanted to share that with you, and we'll just keep going. Here's the Comet Planner tool. It's just a multi-click tool. Really, you can find your state, your county, click on your cover crops, just enter the number of acres, and ta-da, you have a result. That's for planning purposes. So it allows you to understand what are atmospheric beneficial practices and how they are implemented. So we go to the next slide. So in kind of wrapping up and concluding before we go into questions and some answers session, I hope what I've been able to demonstrate is that voluntary working lands conservation, it does deliver climate solutions. We would call this, this all fits under this nice umbrella of a terminology called climate smart. So these are all climate smart practices. Obviously, forestry has climate smart practices. We have opportunities to implement these. And so what we're doing over time is there in the italicized is we're getting more conservation on the ground. These climate solutions, to my second bullet, they're quantifiable, and our conservation legacy effect is important. So how much conservation we keep on the ground is also important, because remember, that's a carbon accrual cycle like the rings of a tree. And the more carbon we can get into the systems, the better it is obviously for the atmosphere, and the systems respond quite positively to that as well. So we're getting more conservation on the ground. We need to keep more conservation on the ground. And then within NRCS, we track those benefits, but we also provide tools to everybody within the continental United States to be able to quantify those benefits and to look at how much of the benefit is accruing in my system over time if I implement the practice, or if I switch from no-till to back to tillage. Let's say if the tools are, the Comet Farm tool is agnostic. It's going to tell you it's a source or a sink. The Comet Planner tool is all based on the NRCS conservation practices that we're trying to get on the ground, and having partners deliver those conservation practices is obviously a high priority. And I probably need not say much more about that. There are some great opportunities that we've seen come out this year about both delivery of climate smart agriculture and forestry. And we expect many more announcements to come in the future. Next slide, please. So amongst the climate community, we kind of hear this phrase, and this is not my quote, this is just kind of common discussion, that, well, we're the first generations to fully understand this problem of climate change, and we're the last generations on the planet with the ability to solve it. And that's kind of the tipping point discussion. It's just something that you hear from time to time. And then I've got a colleague that came up to me and said, well, knowing what you know about climate change, how do you even sleep at night? So if we go to the next slide. I would contend that in our sector, particularly, that we still are the first generations to kind of fully understand this problem. However, I'd kind of modify the second piece of this to say, and we're the first with the tools and the ability to solve it. So it's kind of a change in my interpretation. I think with the ag and forestry sector, we have great opportunities to work with the system to bring more carbon into the system and to deliver what we call climate solutions, climate smart solutions. And it's a great opportunity for the ag sector, in my opinion. And it's also a great opportunity to deliver on some climate benefits that we can hold up and show as quantifiable, and also report back to the numerous reporting entities that we provide our carbon footprint to. So if we go to the next slide. And I think that's it for me until the question answer session. But I appreciate everybody's taking the time and the interest in this topic, and look forward to today's discussion and possibly even some ongoing discussions in November.
Thank you, Adam. Before we ask for hand raising for questions, I just want to take the moment to introduce our facilitator, Phil Singh, who's the president of DJ Case and Associates. He has over 30 years of experience in conflict resolution, facilitation, and project management, really all in the natural resources realm. So I'm going to hand things over to Phil for the discussion portion of it. But Phil, do you want to take it away? And I can cue up the next slide if that works.
Sure. Thanks so much, Lauren, Kirsten, everyone at UMRBA for having me involved. I'm really happy to be part of the effort. I look forward to meeting many of you, hopefully all of you, at our November workshop. And I also like to start by thanking Dr. Helmers and Dr. Chambers again, not only for the excellent content, giving us a lot to chew on, but also for ending not only on time, ahead of time. So we have lots of lots of opportunity for robust discussion, both about the content that they covered, but also those two discussion questions that you see on the screen that Lauren teed up earlier. But we'll definitely start with questions you may have, especially questions of clarification for our two presenters. But before we do that, I just want to go through a couple of quick ground rules for our discussion. We're going to give preference to verbal questions. We like to hear and see people. So if you wouldn't mind raising your virtual hand, and we'll call on you in the order that the questions came in. Please also, if you don't mind, turn on your video just while you're asking your question, and maybe state your name and your affiliation just so that we can know who you are and where the question is coming from. If you don't want to speak, if you have a question but you don't want to speak it, you can put it in the chat. Just know that we're going to take verbal questions first. And so after we get through all the verbal questions, then we'll come back around and pick up the ones in the chat. I think with the amount of time we have, we're scheduled to go till 3 o'clock Central Time. Should be plenty of time to get through whatever questions we have. So I'm not too worried about that. If by chance we don't get through everything people want to talk about, our presenters have graciously agreed to answer other questions in written format. If we don't get through them, I don't think that's going to be a problem. And either at 5 minutes till 3 Central, or when we're out of discussion, we're going to take just 5 minutes to kind of wrap up this session, tee up the next webinar that we'll be having, and also maybe giving a little bit of a teaser for the workshop in November. So please stay tuned for that. Without further ado, I'd like to jump right into questions. So if anyone has a question, either for our presenters or a comment on the discussion questions on your screen, please raise your virtual hand. It's down there in your lower part of your screen as a little hand icon. Click on that and we'll get this party started. Who's got a question? 42 people on. There's got to be a question.
Can I ask Adam a question?
Absolutely.
Because I think he kind of touched on it at the end, but one of the things I've thought about with some of these implementation of practices, but how do we ensure we get the continued benefits? You made the if somebody goes from no-till back to tillage, and we lose all that, and we lose all or almost all that accrued value, is that a level of concern from NRCS and other groups that you work with?
Yeah, I think that's a great question, Matt. And I've put a fair amount of thought into that. It's kind of a permanence question. It's some people call it backsliding. Some people call it normal business. They have to do it. I've kind of seen all of the above. What I've done, and my research on this is far from over, but I think it's a fascinating space to work in, is taking a look at all of our practices and then try to look at what the conservation legacy effect of those practices are. So I'll give you a sample on bookends, and this might get the audience enthusiastic. Let's take windbreaks, for example. So the tree that I showed you at NRCS, we're seeing windbreaks kind of not really going away, right? There are windbreaks on the landscape that have been there since the Dust Bowl. There are new windbreaks, but we're not having a lot of practice implementation. So the uptake of the practice is not huge. But when people do take the time, take the effort, and remember, when NRCS, we also, it's a shared effort. So with a windbreak, you're seeing that they're staying on the ground. So if you were able to get a windbreak in place, it has a conservation legacy effect that's very high. So it's going to accrue carbon like that tree that I showed. Now, if I go to the other bookend, if you might, of the conservation practices, based on the literature that I've been able to review, it's cover crops. If you have the implementation of cover crops, and somebody is working with NRCS or another funder to buy the cover crop seed and to help put that cover crop in place, it tends to stay there as long as somebody is helping with the compensation for that cover crop. However, or there's a value proposition, whether it be on insurance or some other value proposition. However, if you see that as that disappears, if that goes away and you're expecting the producers to carry that forward with that conservation legacy effect, on the cover crops, we don't see that. We see it pretty much reverts back. And so what would happen, you would have kind of a carbon accrual curve in that system for a year, 2 years, 3 years. And then it's going to, obviously revert back to the old system and continue with a downward slope on the carbon emissions. So, this is an area where it's fascinating to me. I wish I could spend 100% of my time on it, but this legacy effect, how do we get that carbon on the ground? So like that windbreak, and then how do we keep it on the ground? Because when you keep it, that's when the system really gets going. Some people say the magic year is 7 if you can get people past 7 years. Other people say 5. I'm kind of agnostic. I'm just trying to look at what's in the published literature and bring that to bear. So we need more research, need more practitioners, and we also need to hear what works and what doesn't work for folks within this climate smart umbrella. Hopefully that starts to answer your question.
Excellent. Thank you very much. We have a hand raised by Dave Wall. Dave?
Yeah, thanks, Phil. And thanks for the great presentations. Matt, question for you on the manual. You have 3 categories, which I really like, and soil health and water quality and all. But I wondered about, did you consider greenhouse gas, climate? Obviously, soil health has some strong connections with the whole climate issue. But I'm just wondering, I'm sure you're trying to keep it somewhat simple too. You don't want to get it too complex. So I just wondered about, how that was brought into the conversation, and are you considering adding that at some point in time? Or, and on a related note, if I could just follow with a question about the water quality too. Some of these practices are good for nitrogen, some better for phosphorus, some have sediment and phosphorus, pesticides, bacteria. So water quality lumps a lot together too, as does soil health. But just wondering, kind of, how did you resolve all that, and what do you see for the future, and looking at it more comprehensively?
Yep, great question as always, Dave. And I gotta, as usual, I gotta put my thinking hat on how do I respond. But okay, on the water quality, I will say we did just boil it down to nitrogen and phosphorus, and so we could have been broader than that. But kind of in part probably because what was or is kind of on the tip of most people's tongue when we talk right now is on nitrogen and phosphorus because of the nutrient reduction strategy. And certainly with the P, we are kind of getting, I would say most of it is really looking at total phosphorus and kind of thinking of that sediment bound. So I guess that's kind of how we made that decision. That's a good one on kind of the greenhouse gas. And so I will say that I don't think there was a lot of discussion back, when we started this about including it. And even this last go around, if we had talked about it more, I probably would have said, let's just wait a little bit, because there is some work that may be going on at Iowa State, among other places, to kind of review the literature similar to how we've done with the Iowa nutrient reduction strategy on nitrogen and phosphorus and water. Similarly for some of the carbon and greenhouse gas. And so I think there's, there are some folks working on that to try to summarize that similarly. So when some of that gets done, I think it could be added into this, into the future. Maybe while I'm talking, there were a couple questions. How are the graphics in the manual used? I think there are some farmers that may use them. We use them in a lot of educational settings to help farmers, I would say. And how did we define soil health? I guess it's pretty broad, and I was hoping there was a glossary that gave soil health, but I didn't find it. So I'll keep looking and see if we explicitly defined it in this manual. Otherwise, we found something to add in the next go around.
Well said. Thank you. Matt Druitt, you're up.
Yeah, this is just for Dr. Helmers, just a couple comments or questions. So I guess the first one is just on, I think you did a really good job with all the different flow charts and decision trees. And I was just, one question was just, if you ever thought about taking those decision trees and putting those into an application, because you pretty much have all the wireframes together. And then the second question is just, I know one thing that comes up with a lot of new saltwater conservation district and NRCS staff out of colleges don't necessarily have like ag practice experience, and it seems like it could work for like doing like some training or certification or take a test on or something like that, which could be helpful. I know in Minnesota they do I think every spring they do like a 1 week training for new staff and in the field, and this could be like a primer for them. But that's all I had.
Okay. Yeah, thanks for those comments, Matt. And one of the things I do think that, there are some, a couple of those slides I showed kind of on like the tillage management guide that I have pulled up here, might give a little information for that, that new individual that may not be quite as familiar to kind of, understand some of what goes along with some of these systems. So there was, I think a little bit of thought that went into that side of it as well. And gosh, as I talked about that, I forgot your first question. Oh, darn it, man.
Oh, just my question was just regarding just the decision trees and putting those into some sort of
Oh, yes.
app or
Yeah.
something.
Because that's a great that's a great question. Sorry, that app I got. That was, I think that might be something PFI is still thinking of doing, at least for the infield practices. So we have had some discussions of that. Yeah. But I don't have anything to show for it at this point. But
Matt, did that get it?
yeah, and I guess what I'd
Yep.
say, Matt, if there's, if any of it's of use, as I said, the PDF will be free, and there'll be a number of copies on the web, to be able to order too. And I think within the group here, we'd be happy to talk to anybody if it would be helpful for training.
Thank you.
Thank you. Kata, you're up. Do you care to ask your question? I see you putting one in the chat as well.
Oh, hi, sorry about that. Yeah, my question is with respect to the conservation legacy effect, which I think is a really powerful idea. And I'm wondering if there's any interest or conversation about perhaps weighting the different recommended practices, climate smart practices, according to those practices that quantifiably sequester the most greenhouse gas emissions or the most effectively, particularly with respect to just the time it takes to measure change in carbon, soil organic carbon, and the amount of time we're really working within to make significant changes.
This is a great question, and I appreciate your interest in this conservation legacy effect. It's been kind of a through life you stumble across things and you're like, hang on, I got to figure out how to solve for this. And there was just not what I thought was enough kind of exploration in this space. And so I kind of started probing down this literature realm in the 2012, 13, 14 timeframe. And then fortuitously, there were some other parts of USDA that were looking for things to work on. And they've really helped kind of propel this question a little bit further. I guess there's kind of the old NRCS response to your question, I think, which is actually true, but I can't get around, it all depends, right? It's one of those, how much carbon could you accrue in a dryland system with, cover crops, which is a wheat fallow, versus what could you, and you might have 2,000 acres in that system. And then what about on the other side, you have a silvopasture system in Georgia that has only 10 acres. So that's where we're trying to meet everybody where they are in this, because those systems are totally different. The land area you have is totally different. The soils are totally different. The precip, everything. So rather than trying to kind of prioritize or hierarchy and say, this is the practice that you should do because this has the most carbon benefit, I'm inclined to do that. I definitely like to go there and rank them and look at the differences, but we just try to meet everybody where they are in their different regions, because that Montana dryland system that I talked about is so different than that Georgia system. And so, we think everybody can do a little bit. And if everybody does a little bit, that adds up to a lot. And so that's kind of the opportunity, I guess, that I would present. And then, it comes back to that keeping conservation on the ground, that legacy effect. Obviously, woody biomass systems that are perennial, they accrue the most. And then woody biomass systems, let's say in hydric soils, where you would stop tillage and put perennial cover on, well, that's gonna stop an emissions and increase a carbon accrual. So that's gonna be kind of your biggest opportunity. If you take a look, and I'm kind of going too far down the path here, but take a look at the national inventory and the source of emissions in the ag sector and the land use sector. And it's really over on those organic soils. They give off a lot of emissions on an annual basis. So we've done a fair amount of investigation into how to reduce that source, and then turn it into a sink. So if we can take the system and stop it from emitting, and then put perennial cover and maybe re-wet those systems and hold them, can you get so much carbon accrual in the system that it pays to do that? Because sometimes those can be highly productive systems when they're not so soggy. So it's definitely a balance. I wish I had a single answer for you, but it's kind of that what if answer. I apologize, but hopefully I've explained why.
Yeah, thank you. I think just with reference to kind of the zone that our group works within, there's been some recent research coming out on cover crops, and they're and looking at the meta-analyses to look at the soil organic carbon gains with winter cover crops, where we have a very short period in which those crops can grow. And so, I think you spoke really well, though, to the challenge of doing that nationwide. But it might be interesting regionally to kind of adapt some of the quantifiable research into regional assessments.
And the other thing that I try to convey to myself, and then hopefully I can articulate it to an audience as well, is that if we stop an emission source, there's benefits associated with that. And then if we add carbon sequestration, there's also benefits associated with that. So it's kind of the net delta of baseline to the conservation scenario, which sometimes is bigger than just the conservation practice implementation. So you reduce emissions and then you get an incremental carbon benefit to the system, which from an atmospheric perspective is larger than just one of the wedges. There's kind of two wedges, if you might, that make up the total emission benefits associated with that. So
Thank you.
There's a lot of work to be done here too. So thanks for your interest.
Great, thanks very much. So Betsy, I had what I think was a comment of clarification. You want to speak that? And then there was some comments on your comment, so maybe we can clear that up.
Yeah, hi everyone, and hi Adam. I am Adam's colleague. I'm Betsy Deerberger, National Agronomist with NRCS. And so what I had added in was that we also have states have a lot of flexibility in what they can work with their state technical committees to give input on high priority resource concerns and direct funds toward high priority resource concerns, as well as they develop some tools that they use when they're looking at ranking producer applications, and if the greenhouse gas or climate smart is a priority for that state, they can adjust those tools to kind of award recognition to those people searching for financial assistance contracts through NRCS. And then I was going to remind Adam was talking about the legacy effect and, keeping practices there. And when we plant trees and windbreaks or tree and shrub planting or anything, we're expecting those to be around for like 25 years. And if we came out to visit you, your 25-year windbreak should still be there. If it's not, we're just sad because there's not really much we can do. At that point, we are no longer contractually obligated with you. So, but some of the other conservation practices, like Adam mentioned, especially cover crops that are 1-year lifespans, because you implement them every year, really are unfortunately more dependent on, can I get this cost covered in some situations, rather than recognizing the good effects of cover crops in your conservation system. And I think we see potential when I tried to change the cover crop standard. I heard all sorts of people use it in all sorts of ways that I didn't know about. And so not to confuse that with conservation crop rotation, where some of your overwintering plants like winter wheat or camelina might be in your rotation that are actually cash crops in a rotation, but also function as cover crops during that part of the year that normally would have not had plant cover. So that's something we still struggle with at NRCS on how to promote and encourage both cover crop and conservation crop rotation. And yay, Adam shared his list. Excellent. Lifespans for the practices are found in the National Handbook of Conservation Practices. I would be able to get you a link to that. I don't have them memorized. So that's all. Thanks.
Very good. Thanks for those clarifications. Excellent. Let's see, Brad Redlin, you're up.
Thank you. I apologize at the outset. This is a little bit of that obnoxious participation. I'll be talking about work that we do rather than asking direct questions. But I think there's just some definitely through lines here that I just wanted to highlight and touch on with actually both presenters. But when I speak in particular is about the Minnesota as an agricultural water quality certification program that we do with farmers in our state. Housed at MDA, but actually brings along our Board of Water Soil Resources, Department of Natural Resources, USDA, NRCS, EPA, Soil and Water Conservation Districts, and some private industries like Hormel Foods and Land O'Lakes and others are participating with us too. But the whole farm conservation, but that's, that actually the through line through my career when I was working on Capitol Hill policy lobbying or working at the state now, is that that's something we've always sought to achieve. I love to see the product that is being produced in Iowa. But I think it's fun to see that that's really the application of the certification program, where growers really, they just sign the application, electric water quality certified. Our process is to go out and every field, rented or owned, walk and risk assess it, find out what options are, or what conditions are, what options for interventions exist, which ones are particularly appealing to a grower, which combination of them are particularly appealing to a grower, and really kind of working through that flow chart through one-on-one at the kitchen table with the conservation professionals there to serve them and walk them through each one of those decision trees live and in person. So we're excited about that. It seems to be working very well. It takes some of the need for the farmers self-motivation. They have to go out and seek the certification, but they don't have to figure out all those things. We'll go through the rotations, we'll go through the physical factors, all that stuff. And then rather than just talk about what we do, I want to circle it back to the point that on the legacy aspect, one neat thing that we've realized through our work though too is that these are 10-year certifications, so that they're 10-year commitments. EQIP contract's going to be 3 years, but that conservation is going to be there for 10. And particularly given practice. So we're appreciative of how that is working out for us. A cover crop is a 1-year contract, but it's 10 years when you're certified, because they have that commitment throughout that. And we hope they recertify after their 10 years. We just haven't reached 10 years of this program yet. While the growers are out there, or excuse me, while our certifiers are out there doing this work, they're also checking the lifespan of anything that's existing out there. To make sure that it's within that lifespan, or if it's not, that we update it, or just the water's cutting down the side of the waterway rather than through it. So all those types of things are fixed as well too. So we like how that works out for us. But perhaps one of the things we like even better in terms of legacy driver is that through independent study from state colleges, they've reviewed the actual financial reports of the farms participating in our program and those who aren't, and they found that all of our farms have been consistently over 3 straight years 25% more profitable than the farms that aren't certified. So when they get that high level of whole farm conservation, it does show up in their bottom line. And then lastly on the point, I'm sorry taking so long, but lastly on the point of the multiple benefits, that's something we approach and stumbled upon almost in a different way, is that we certainly recognize there are multiple benefits to any given practice, but we weren't always capturing them. So we basically dreamed up this idea of creating further endorsements for water quality certified farms around particular topics. So soil health is one, integrated pest management one, wildlife habitat's one, irrigation management's one, climate smart farm practices are one. We use climate planner in that. So that you have that same one-on-one opportunity to talk in further detail about, you may not realize that, your CRP buffer is great wildlife habitat, but it is, and you could do probably so much more on your farm if you were at all interested in that. We're standing here right now to locate the funding sources, the technology, the support, whatever that you have. So I apologize for sounding like an advertisement, but I just wanted to contribute to this group that, this is such good work, and we want to certainly further our efforts, but I also wanted to give a little window into what we're doing in Minnesota too. Thanks for your time.
Thanks for that. Matt or Adam, any rebuttal? Any comment on any of that?
Conservation partnerships are the key, I guess, from my perspective. If you kind of look at from the NRCS perspective, I kind of look at the agency and get to kind of observe what's going on and how much conservation we are getting on the land. And let's just say there's a huge conservation opportunity, and we need to mobilize kind of all partners to go together on this. And I think that's the solution. It's a leverage solution, not we're just going to come in and solve all of it, because I don't think there's one organization, corporation, entity on this planet that can do it by themselves. It's going to be this team effort, and we have to meet people where they are in every state and every circumstance, but we can all do a little bit. And then the amount of that little bit really piles up to a lot cumulatively. So the partnerships are the only way that we're going to do this.
Thanks, Adam. Matt, you want to, any comments on Brad's comments? If not, Matt, you want to take a shot at Dave Wall's question in the chat about the Iowa manual?
So I think that's a great question, Dave. I think in general, there would be a fair bit that would apply. There are going to be some things probably specific to things like maybe the cover crops or like the diverse rotations where there's some differentiation between south of I-80 and north of I-80. Obviously, that wouldn't be. But for things like, kind of the flow charts, decision trees for some of the edge of field practices, I would hope that those, would be relevant to other states where they're implementing those practices.
Okay, thank you. I'm not seeing any other hands raised or questions in the chats. Any other comments, questions for our speakers before we get back to the discussion questions? This is your opportunity.
Actually seeing Suzanne's hand raised.
Okay, thank you. Suzanne.
Yeah, hi. Suzanne Reese. I'm with another Minnesota participant like Matt with the Board of Water and Soil Resources. But it's interesting to look at that chart that shows that Betsy sent that shows the duration of the practices. And you realize that for anything that's related to annual crops, it's just the length of that growing season. And it kind of it highlights how difficult it is to know what level of sort of permanence to assume about these practices. We have a couple of soil health planning efforts going on here in Minnesota, and we've had a literature review, which at this point is not really very supportive. The wisdom coming out of it does not seem to be supporting the whole Comet Farm, Comet Planner system because basically you've spent so much time losing soil carbon through cultivation. I guess the question is, how long is it going to take to really get it back? And at I guess the question for Adam specifically is, what kind of assumptions do you make in the Comet system and the other calculations about the duration of something, the average duration of something like cover crops, when you're deriving that reduction in emissions, the reduction in CO2 equivalents? I know we also, there's another study that was done by our pollution control agency, and that researcher averaged everything to 20 years. So obviously hedgerows are longer, easements are hopefully permanent. Cover crops can be anything from 1 year to permanent. So how do you come up with that average?
Great question. Thanks for the question. I'll try to answer it and see if we can talk about the two different tools there's completely separate tools, and not just for everybody's sake. There's a tool called the Comet Planner, which is going to assume your localized kind of business as usual, and then the implementation of an NRCS conservation practice. And so this is, as it says in the name, it's a planning tool. So it's trying to take your baseline of zero conservation implementation and project it forward for 10 years that you're going to do these practices. And what that does is that allows us to plan, to be good planners. That there have to be assumptions in there. We have a manual that accompanies the Comet Planner of how we implement the practice in across the whole country. And then we use this meta modeling approach. So we'll model the whole baseline of the country, and then we'll model local specific conservation practices, and then look at the difference. Now that's, again, just for planning purposes. Now the Comet Farm tool is going to require a lot of data, and they're going to ask you to go in and digitize your field. Then we're going to pull in the soils, we're going to pull in the meteorological conditions, and then we're going to go back to the 1980s and ask you, was this landing in the CRP program? Did it have intensive tillage? And we're going to work up to today. And what that's doing is that's trying to optimize for your carbon stocks on your field with your soils and your meteorological conditions. And then you can implement whatever practices you choose. And again, you can be a source, you can be a sink, you can increase soil carbon stocks and also increase nitrous oxide emissions. And the tool will tell you kind of here's what's going on in your system. So it's going to grow different crops, and it's going to be very specific to the field. And that's more kind of a what if scenario of how much carbon will be accrued, or how much nitrous oxide will be lost, or how much methane will come off of manure-based system over time. And again, that's all kind of based on this big blue book that USDA has published. So the Comet Farm tool doesn't venture outside of the bounds of this big book. And then we update the methodologies every 5 years. So that's kind of the published barriers or sidewalls to how we do the calculations with Comet Farm. And again, Comet Planner, everybody's baseline is the same, which is no conservation scenario. We know that's not the case. Some people may have implemented conservation in the past. Some people may start from different places, but we can't have infinite selection as well. We then would push everybody over to use your customized Comet Farm tool. And again, you know, this is science, right? It's the journey is the opportunity to continually grow and explore and improve. So I definitely appreciate the locality specific needs and your local demands, and those are entirely valid. You may have great research in your region that helps you advance your conservation missions as well. So
No, I think the Comet tools are great, and I wish we were seeing more use of them in Minnesota. Actually, it seems like the adoption hasn't been that widespread. But am I correct then? Did I hear you say that you use an average of 10 years for the planner tool?
yeah, that's a great question. So let's go into this just a little bit more. It seems like we have time. There aren't too many questions.
Sorry.
So let's take cover crops, for example. CPS 340, NRCS practice standard. So what are we going to do? We're going to use, in the Comet Planner tool, we're going to model, using the Comet Farm tool, a whole bunch of cover crop implementations in Minnesota on different soils. And we're going to start from a baseline of 0 cover crops. And then we're going to project that out 10 years. We're going to look at carbon accrual across 10 years. And then we're going to annualize that back to every year across a decade. There are assumptions built in there. That legacy effect that I talked about, if we don't invest in that cover crop year on year, you'll get, those benefits, but then they're going to go away. The Comet Planner tool doesn't really have the capabilities to tell you that, if you only do it for 3 years and then you go back to 0 for years 4 through 10, you're going to end up here. That's just kind of a little bit out of the planning realm. And so then that would move us over to Comet Farm, and we would do the calculations there. So what we're really trying to do is give people a tool to start the planning process. And if we remove those tools from the discussion, we kind of had nothing. And there was no way to really have a discussion about what benefits are available. So we kind of propelled ourselves forward, built the tools, fully aware that they're not perfect. And we'll have a new set of data tables come out this fall. And that's not going to be the last. We want continual improvement. And I think that's, what USDA is trying to be here to do is to try to help people make some investments in this science, and then rely on our land grant universities and all the peer-reviewed literature to kind of propel this space forward. You kind of may have heard a subtle ask there of help me with the conservation legacy effect. Whether you're in Iowa, Minnesota, or Vermont, I need that help. And hopefully we'll ignite the scientific process that can just continually move forward, and we will all be better for it. So I appreciate your comments. Great questions. And I hope I've kind of been clear in my wordy explanation.
Great, thank you very much. Our next question is from Guolong Liang. I apologize if I'm not familiar with your name. Please correct my pronunciation.
Yeah, it is Guolong Liang. It's pretty good. So extension outreach specialist from UW-Madison. I have a question for Dr. Helmus. So in the conservation at glance, the page 5, there is a confidence section. Can you talk a little bit more about that? And as an outreach specialist, I'm always thinking about ways to communicate this type of material to farmers, and how can we better facilitate the process of adaptation. How do you see this type of manual in that extension process?
So that confidence, that was a fair bit of that was scientific, judgment of those summits to, as well as review specifically on the nutrient loss reduction. Kind of what we found when we had done the science assessment of the Iowa nutrient reduction strategy. And so I guess, one thing, I think of when we talk to producers is that, maybe that higher confidence, gives them some comfort that these are the practices that are going to do what we say they're going to do. Some of those that, with the lower confidence, there maybe we're trying, but we may not have quite as much. Maybe we aren't quite as sure at this point in time that we'll get all the benefits that we expect, and maybe there's a little more information that's needed.
Thank you.
Thank you. Good question. Any other questions for our presenters? If someone's still typing, we can come back to it, but let's shift now to those discussion questions on the screen. We've talked a lot in preparing for the workshop and the webinars about the different terms, the lexicon that we have for this when we're thinking about conservation practices with multiple benefits. How does your agency organization talk about that? And I don't know the best way to handle this first part of the question. You maybe just type into the chat what term, if there is a set term that your organization or agency uses, but I'd really be interested to hear from you why, if you know of a reason. And maybe there's some specific, maybe it's set in statute, maybe there's long-term tradition within an agency, whatever those things are. I think I would like to start a conversation or discussion around not only what the terms are, but why we have the different ones that we have. Who wants to jump into that? So Adam says he's used co-benefits and ancillary benefits. Can you you want to expound on that any as to why those particular ones?
Sure. I guess I've worked in this space for quite a while, and in about 2006, the Intergovernmental Panel on Climate Change worked to define both of these terms, and so let's take a scenario of co-benefits. So we have, let's say, an atmospheric benefit and a water quality benefit, and we implement a practice to to deal with both of those at the exact same time, so that the practice is implemented, and we want to get both of those on the ground at the same time. We want to harvest the what we call ecosystem services for water quality and the ecosystem services for atmospheric benefits, and you put that single practice together in and expect those dual results. That's what we call, as I understand it, co-benefits. And then if let's say we have a climate solution, we put that forward and we realize that it has forage benefits for animal agriculture as well, but we didn't anticipate that at the inception of the implementation. That would be what we call, it's another benefit, obviously, but it's an ancillary benefit because it wasn't at the inception, it wasn't an intended practice, implementation, or requirement, and it came along kind of as an ancillary benefit. And those two terms are fairly well defined by the Intergovernmental Panel on Climate Change. Doesn't necessarily mean that there aren't other terms. It just means that I like to use those two because they have clear and succinct definitions in how you value or evaluate the second piece of this, which is ecosystem services.
Within the community, would you say there is a push or a need for trying to use fewer terms for these same concepts, or is that something that the community is talking about?
I think the community could definitely use to harmonize behind a few definitions. We have other terms that are harder to pin a definition on, and others definitely, like regenerative agriculture. I've been in 3-day workshops where we tried to define it. It's really difficult, but in these two terms, I think that fortuitously, or at least there is a definition on the books from 2006 timeframe, and so if we can come to align with those definitions, maybe we need other terms defined, and that's scientific growth as well. But if we can start to use succinct terms, my undergrad's in engineering, so I'm always trying to put things into linear systems, which is not always correct. But that's just the way I think.
Great. No, thanks for those thoughts. I'm seeing ecosystem services, ecosystem benefits. Kathy, you mentioned natural climate solutions, but you have a fair amount of description there. Do you want to talk us through that, what you put in the chat?
Sure. So we define natural climate solutions as really a suite of any landscape management practices that not only conserve, so keeping what exists as best we can, but also protects and regenerates that ecosystem, whether it's a working land, a forest, a wetland, etc. And we then further kind of refine our focus, particularly in Wisconsin, where we're based, to look at the largest source, an increasing source of greenhouse gas in our state, which is the agriculture sector. It's the only sector that actually has increased since 2005 and significantly by 14%. And so we focus on climate smart agriculture specifically because a number of different kinds of practices, whether they're conservation agriculture, sustainable agriculture practices, or regenerative as defined by regenerating the soil health, all of these can contribute to having positive outcomes on climate mitigation of greenhouse gases, particularly carbon, nitrous oxide with nutrient management, but then also in Wisconsin, our dairy farms and livestock farms have significant are significant emitters of methane as well. So we use climate smart agriculture to focus on practices that ultimately have a significant impact on both sequestering the greenhouse gases and also mitigating the worst effects of climate change. And that's a little bit why I was pushing back a little bit on cover crops, because we found both in McLeland et al. In 2021, and there's another meta-analysis in 2020 that found that in our state, cover crops really aren't statistically significant in terms of soil organic carbon gains. But that's not to say that they don't play an important role for water quality improvement and keeping the soil in place. But we just discern the difference and hope with the hopes of continuing to encourage people to cover their soil, even better if it's a perennial cover crop. But really as almost like a gateway drug, if you will, to better practices that will sequester more greenhouse gases at a faster rate to where we need it to be in the next 7 to 10 years. So that's a little bit more about our approach.
Oh, thanks. That helped me a lot understand what you were putting there. So thanks for that description. Anybody have comments or comments on Kata's comments?
Dave has his hand raised. There, Phil.
Hey, Dave.
Yeah, just following up on the last comment with cover crops. One thing I've wondered about, and maybe a question for Adam, but if NRCS accounts for the nitrous oxide emission reductions that would occur downstream of the field. So if you don't have cover crops, there's going to be more nitrate leaching. They can get in tile waters or ground waters that end up in the streams that then get into backwaters, and eventually some denitrification occurs, some nitrous oxide is emitted. Does the NRC, I mean, is that an important thing to also consider when we look at greenhouse gas emission reduction, is kind of the downstream denitrification and nitrous oxide emission?
Absolutely, and that comes from all sources of nitrogen, right? So I think, well, in just my kind of gazing across the literature and the enthusiasm right now, there's a lot of interest in soil carbon and soil carbon sequestration and the discussion around that, and that's really exciting. But in the United States, if you kind of just look at the numbers, nitrous oxide is 50% of the ag sector's carbon footprint, if I recall correctly, and that's coming from fertilizer from nitrogen in the systems. And so I guess backing up, I kind of spend a lot of time with the national inventory. The US ag sector has a carbon footprint about the size of France. So and that's just the ag sector's carbon footprint. It is increasing ever so slightly. About 10% of the US total carbon footprint is ag. And then you get into that 50% of that being nitrous oxide. Then we go into what we call the indirect emissions, which are if you get runoff of nitrogen into aquatic systems, and then the denitrification and the loss of nitrous oxide into the atmosphere. Within NRCS proper, we're not doing the indirect emissions calculations, but within the National Greenhouse Gas Inventory, it's actually an empirical calculation. I think it's 0.5% or 0.75% of applied fertilizer that ends up in the system. It's definitely cited in the national inventory. But yeah, that's a great question. In NRCS, we're trying to work on the other side of that. What if we put in a grass waterway? What if we can kind of collect that nitrogen before it gets into the aquatic systems and use it in some way, shape, or form to avoid it getting in? And then we can get the co-benefits of the carbon benefits and the reduced nitrous oxide. So so we're kind of trying to look at it through the conservation practice implementation lens and deliver solutions to what's accounted for in the national inventory.
Thank you.
Yeah, great. Thanks. Other thoughts about this terminology? Big picture way. About the second question there, how your agency or organization emphasizes it, if it does. Does it? If so, how does it? Everybody talked out? Okay, Dave, have at it.
Yeah, just waiting for someone else here, but just since while others are thinking about it, maybe I wanted to mention, yeah, I work with Minnesota's nutrient reduction strategy, and that's probably my primary role. But in the last year, I've been fortunate to work with a couple of other teams, and Suzanne Reese and Matt Drewitz, others who are on the call, are also been part of this work. But looking at the whole water storage issue, and there's been a water storage team to look at ways that we can store more water in the landscape and reduce our peak runoff and reduce flooding. Also been on a team, working lens team for our climate change framework that's being developed in Minnesota. And as I look at the nutrient practices and the practices for climate change, and I look at the water storage practices, there's so much overlap there that I kind of go back to my nutrient reduction strategy and think, you know, is it really best to look at how much it's costing to reduce each pound of nitrogen in a practice and evaluate a practice that way, as opposed to looking more holistically as far as the practice impacting greenhouse gas emission, carbon storage, water storage, et cetera, wildlife. And so, yeah, we're really starting to think about that with our nutrient reduction strategy. How can we, and that's why this is a real timely workshop, how can we do a better job at looking at the multiple benefits, combined benefits, and maybe cost benefit in at least some cursory way that looks at the combination of practices as we weigh it against, or a combination of benefits as we weigh it against the cost.
Is that directed at anyone in particular, or looking for?
No, but Matt, I mean that you know, you've been probably thinking about these similar things in Iowa with your nutrient reduction strategy, and do you have? I mean, how are you guys looking at it? Are you trying to combine any of these benefits as you're looking at the nutrient reduction strategy quantitatively or even qualitatively?
That's a good question. I don't know if Matt Lechtenberg is on, but you know, I think that probably not quantitatively, although we've had that discussion about that is something, you know, with at least within the scientific community, we've had that discussion that that we need to do that. You know, like when we looked at the cost effectiveness, you know, like cost per pound of nitrate reduction. I mean, we assigned that whole cost to nitrate reduction, but it does provide other benefits. So I think, you know, we need to do more of that. I would say, you know, there's maybe a little bit of that thinking as, you know, as we think about something like, you know, a wetland might provide many other benefits beyond what a bioreactor would. And, you know, I don't know if that precludes us putting in bioreactors, but, you know, might influence some thinking that if we have a choice, you know, perhaps a wetland or multi-purpose oxbow would provide some of those other benefits. So it's maybe a little more qualitative than quantitative, I guess.
And I believe Matt Lechtenberg is on. Matt, you want to take a crack?
Yeah, I was just going to chime in that Dr. Helmers is kind of in line with my response. I mean, we have quantified some of this stuff with dollars per pound, but even beyond that, and this can kind of dovetail with some of the permanence questions too, or the longevity questions that, you know, many of these practices, the infrastructure type practices that have these multiple benefits are very costly, don't have a benefit to landowners, are longer lasting, all of those things. And so that factors into that. And then, you know, then it's an argument over how long you're going to require somebody to maintain and keep that practice in, and you know, costs are continuing to rise, and so it all changes. But I guess we look at it in kind of those buckets that have been placed for the categories of practices. You know, management practice, we know they're short term, but they're typically less costly. And you have the question that always comes up of how long that's going to be maintained, and so that, you know, that factors into program deployment, but it also you know, gives up some assurance that it's going to be there long term. Whereas, you know, some of these practices that have you know, longer lifetime but are more costly, take more time to develop, those types of things. And so, you know, if it's something that's going to be harder for somebody to convey to a landowner to put in, then it probably takes more public sector involvement to decide and to help foster those practices, as opposed to those ones that are a little bit easier to fit in the landscape or an operation.
Very good. Thanks, Matt. And that's a good place, I think, to close our discussion. We have 5 minutes left. Please don't bolt yet. I'm going to pitch back to Lauren for our wrap up and segue into the next webinar that's coming. But before I do, I just want to thank again our speakers, and thanks to all of you for the discussion. I think it was a robust discussion and something that we can carry with us into both the next webinar and also to our get together in November. Hope to see many or most of you there. Lauren, all yours.
Thanks, Phil. Yeah, so just a reminder, we've got our next pre-workshop webinar on October 5th, the same time. We'll be hearing from Illinois Department of Ag's Dr. Michael Woods on the Illinois Climate Smart Ag Partnership, from Wisconsin DATCAP's Dana Christel on the farmer-led performance-based conservation, and then from Illinois Corn Growers, Dr. Laura Gentry on Precision Conservation Management Program. And the goal of this webinar is just for us to discuss examples of leveraging state and partner resources to advance adoption of conservation practices with multiple benefits. If you don't have the calendar invite on that, please let me know. Feel free to reach out. My contact information will be on my very last slide. And we are able to extend this invitation just beyond those invited to the workshop. So you are welcome to forward that, or again, ask me to send out email invitations to others. Another just plug here for our great workshop we have planned. So we'll have a lot of information sharing and breakout groups. So a lot of this kind of conversation like we just had. And so we've formed around 3 main topics: research, communication and social science, and then the financial tools. So we have kind of a fun activity. I don't know if you have ever used these virtual business cards before. Padlet is a way you can get to know your fellow workshop attendees in advance, kind of serve as a little bit of an icebreaker beforehand. So I bravely put mine forth and you can see it. And I guess in between now and the workshop, please fill it out. And in addition to that, we are hoping to organize a in-person networking event either the night before or the night of the 9th. If we are able to organize that, we will let you know. And then lastly, thank you to the planning committee. They've been instrumental in putting this together. We are just sort of helping convey and coordinate this on UMRBA's end. So really, really appreciate all these folks here coming together to help plan this. So my last piece is just leaving you all with my contact information. If you have any questions or comments, we are excited to get this kind of kicked off. I hope you can join the October 5th pre-workshop webinar, as well as the November in-person workshop. So Phil, I don't have anything else. I think we can kind of close out today and thank everyone for their time.
Agreed. Thank you very much.
Thank you all. Take care and have a great afternoon.
Thanks, Lauren, you too.